Hey, what's up YouTube? Welcome to PyAlchemy. And today's tutorial is gonna be about object-oriented programming, and we shall see its implementation in Python language. So, these are the four core pillars of object-oriented programming. Starting off with encapsulation, the protective shield. Encapsulation is all about data protection and control access. In simple terms, it's like putting your data and methods into a capsule, the class, and deciding what stays private and what can be accessed publicly. This prevents external interference and ensures that an object's internal state remains safe. Technically, encapsulation is implemented by using a private and public members, getter setter methods, and access modifiers. It enforces clean separation between an object's internal logic and how other parts of the program interact with it. Then we have inheritance, reusability, and hierarchy. Inheritance allows one class to acquire properties and behaviors from another, forming a parent-child relation. It promotes reusability and logical structure in complex systems. For instance, if you have a base vehicle class, cars and bikes can inherit its features while adding their own. Technically, inheritance helps avoid redundancy and supports features like method overriding, multi-level hierarchy, and code extension, making software more scalable and easy to maintain. And then we have polymorphism. One interface, many forms. Polymorphism is the ability of a single interface to represent multiple forms of behavior. It allows different objects to respond to the same function call in different ways, depending on their class. In technical terms, this can be achieved via method overriding at runtime or method overloading at compile time. This flexibility enhances program extensibility, meaning new classes can be added with minimal changes to existing code, a core principle of robust software engineering design. Then the last one, abstraction, hiding the complexity. Abstraction focuses on simplifying what's visible and while hiding unnecessary details. It lets developers interact with high level functionalities without worrying about what happens behind the scenes. Think of it like driving a car. You only need to know about how to steer, accelerate, or brake. You don't need to know or understand what the combustion process inside the engine does, unless if you are an enthusiast like me. In OOB, abstraction is achieved through abstract classes, interfaces, and method overriding. In Python, we need to import abstract method from the module name ABC. This reduces code clutter, improves modularity, and allows programmers to focus on what's important rather than how it's done. And now we shall see how each of these work. So let's get going with the practical implementation of these four core pillars. First one being encapsulation, which means binding data and methods together while hiding the implementation details from the user. So let's first define a class named portion. Then we'll define the constructor with double underscore init, parameters being self, name, and ingredients. So this line assigns the portion's name to the object. When we use this double underscore, we gave it a private attribution, meaning it cannot be accessed directly from outside the class. Think of it as a sealed jar of ingredients. You can't open it directly. You must use the right method. Self refers to the main object being created, which is this one. This word self. So let's make the brew, which defines the behavior of the potion. So this defines the behavior of the potion when you call it, which is dot brew. Then it prints a message showing which potion is being brewed. Then we'll define the get ingredients function. And this shall return us the ingredients. So this is the classic encapsulation, which is giving control access. Since double underscore ingredients is private, so you cannot access directly. So this method provides control access, a getter. So you can still see what ingredients were being used safely. Now we shall see the usage by creating an object. Suppose health potion. This will go to the name. And then herbs. Sorry. Water. And honey being the ingredients. And these will go to here. Health potion dot brew. Now if we want to print the ingredients, we shall call the get ingredient function. We have to use dot get ingredients because we cannot access the ingredients directly, as we have used a private function here by writing two underscores. So this was how we implemented encapsulation. We first created a class named Potion along with its constructor containing name, object, and a private attribute which can only be accessed by a getter function named getIngredients. Remember, the key here is to make attributes private by using double underscores and make a getter function to access them. We use double underscores to make attributes private. Access is only given through methods. Now, we shall see inheritance, which is the most commonly used pillar of OOP. So, inheritance, as we all know, allow a class to derive properties and methods from another class. Let's define the potion class again. Brewing function. This shall print brings the name of the object. Now let's create the child class named healing potion, which shall inherit all the properties of its parent class, which is potion. We will define the constructor first, same way, and double underscore init. Self name, and now we shall add one more parameter, potency. Now see what I will write: super dot double underscore init double underscore then name. So this is used when we want to inherit properties of the parent class, which is portion. Then self dot potency, which is specific to this child class, equals to potency. Now we shall create a function similar to brew, which is heal. So this is how we created our child class healing potion, which did inherit the properties from its parent potion. Now we shall see the usage of doing all this with an example in which we shall create an object. We first call the child class, and we'll give a name to the potion as strong healer, with the potency being 80, suppose. Then now we'll call hp.brew, which is not from the child class, but we did inherit it from the potion class, which is the parent class. Now we shall call the property from the child class itself, which is hp.heal. Okay, so this is the output that we have received. Brewing strong healer potion, which is from hp.brew, a property that has been inherited by healing potion from its parent potion, and the property is brew. And then we have got a strong healer potion, heals with potency 80, which is indeed a property from the child class itself, heal. So, healing potion inherited properties from its parent class, potion, and returned with stuff specific to it, specific to healing potions. So, this was all about inheritance. We saw how healing potion, a child class, inherited properties like brew from its parent class, along with its own properties like heal, and we could access both the properties by creating an object to the child class. Now moving on to polymorphism, which means many forms. Just like adopter, it allows object to share a common interface while behaving differently. We shall create the potion class again. Now defining brew directly. Brewing a generic portion. This is your base class. Now with the child class, healing portion again, inheriting properties of its parent class portion again, herbs and honey. And now we shall create another child class. Name something like a mana potion, inheriting from its parent potion. Define brew. Printing. mm, Brewing a magic potion, suppose. Okay, now comes the key part. How we shall see different behaviors from the same class. Now we shall implement a for loop for potion in potion, mana potion, potion.brew. See, we got brewing a healing potion with herbs and honey and brewing a magic potion. So, same method name, different behavior. Both healing potion and mana potion are treated as objects of the same type, potion. Yet, when you call brew on each, Python automatically calls the correct version depending on the actual object type. So each subclass did implement the same method, which is brew, differently. That's polymorphism in action. Now let's talk about the last pillar, which is abstraction. Abstraction means hiding complex details and exposing only the essentials. To achieve this, we shall use the ABC module. So from ABC, import capital ABC, comma abstract method, creating a class portion, at the rate abstract method, defining brew again, and then pass. So what we did here is that potion is an abstract class, inherits from ABC, and brew is an abstract method. It defines that any potion must have a brew method, but the actual implementation is left for subclasses. We shall see that now. Let's create a subclass named healing potion. Brewing a healing potion with medical herbs. Similarly, now let's create a class again named mana potion again. Defining brew. And this shall return us brewing mana potion with magical ingredients. Now we shall see the usage of doing all this by creating two objects. P1 equal to healing potion and P2 equal to mana potion. P1 dot brew, P2 dot brew. So as you can see, we have got brewing a healing potion from medicinal herbs, brewing mana potion from magical ingredients. So what we did here is that, let's come to healing potion class. It implements an abstract method brew. Now you can create an instance of healing potion and call brew. Let's now understand that why is this abstraction. The user of healing potion or mana potion doesn't care about what the internal details of brewing are. They just know that every potion has a brew method. The abstract class potion defines the interface and the subclasses provide the details. And please note, abstraction helps hide details and enforce a common interface, but it must be implemented by the subclasses. The abstract class portion defines a blueprint, and subclasses must implement the brew method. And that's all for the four core pillars of object-oriented programming in Python. So, we have seen the practical implementation of each of the four pillars of object-oriented programming in Python, and now we shall see the working of all of four of them together in a small project. So, let's get started. So, in this project, we shall use encapsulation for ingredients, inherit base potion behavior, apply polymorphism for different potion types, and employ abstraction for the base design. So let's call ABC model again from ABC and abstract method. First, for abstraction, we define a class potion ABC just like before, defining the constructor double underscore init. self name ingredients. And this was the part for encapsulation. Now as for abstract method, defining brew, pass, defining the getter method for the private attribute ingredients, get ingredients, returning the ingredients. Now we shall create another class healing potion again because we do love our potions. Defining brew, printing potion with the ingredients we shall call from the getter function. This heals wounds instantly. What did I miss? Oh, sorry. Defining mana potion class again. This shall print and what they do is they restore magical energy. Now let's create another potion of the type combat potion. This shall print. Potion with the ingredients. Oh, I did make a mistake. This is get ingredients, not simple ingredients. And this will help you in combat. Now it's time for demonstration. So we'll demonstrate these by creating a potion object. Elixir of vitality. Ingredients being herbs, honey, and water. Next we have our mana potion named Essence of Focus. Made with magic dust of some sort. Let's take crystals, if that's right, and mandrake roots of some sort, like whatever. And now, as for a combat potion, let us name it. Okay, what the hell? Black blood. So, if you know what that is, it is used for fighting against vampires. So, it shall have ingredients like wolf's bane, mm, ether, nostrix, if I remember correctly from the game. And now we shall print these for potion in potions. Potion dot brave. See what we have got. Brewing elixir of vitality, potion with herbs, honey, and water. Similarly for essence of focus and black blood. So, this is how we implemented abstraction, encapsulation, and here we did implement inheritance plus polymorphism. So, how did we implement all four pillars? Encapsulation for private ingredients with getter method. Then we used inheritance for all potions, inheriting from the parent potion class. Then we use polymorphism for each potion, overriding the brew differently, showing different behaviors. And then abstraction for potion is an abstract base class that enforces structure for all the subclasses to follow. And that's how object-oriented programming works in Python. Today, we role-played an alchemist to understand these four pillars of OOPS concept. And that's how object-oriented programming works in Python. Today, we role-played an alchemist to understand these four pillars of OOPS concepts in Python language. Now, the implementation in Python for OOPS may differ from other languages like Java or C++, mainly because of syntax, type system, and underlying mechanism for all these languages. But the core concept remains to be the same, and that's what we are here for, to understand the core concept. So as you know, this was the first video. So on this channel, we'll be looking concepts like these in mostly in Python language. I mean, yeah, mostly it's going to be Python on this channel because it's the language of tomorrow. I mean, just look at the stats. It's ruling in 2025. It's way above, not like way above, but it is above Java or C++. I'm not saying that those are bad languages. I mean, if we look at the game development domain, they are still ruling, and Python is nowhere near. So I'm saying that because it's being used everywhere. See, in data science, analytics, building advanced systems with AI, machine learning, etc. It's on the boom. So it will be beneficial for everyone to get a good grip on this language. So that's all for today. I hope you understood today's topic well. There is a practice question in the link in the description. Make sure to practice and check your code with the solution provided. Also, there will be this notebook available for you to refer in future. Take care, everyone. Take it easy. So long.